Yep.
Okay. Hi everyone, welcome. It's a pretty big crowd tonight. Okay, so we're learning CAD tonight. So who here has experience with CAD? Does anyone here have previous experience with CAD? There's a couple of people. Okay. All right, so my name's Joel. I'll be talking about just about why CAD's important and what it can be used for. And here's Chris. He'll actually be taking you through the CAD itself. So, CAD, or computer-aided design. So CAD is a way of designing things which enables you to send information directly through to machinery to have it made. So the reason why CAD is important is it enables you to get machines to make things for you in a really fast and efficient way. So that's really why we design things with CAD. So if you want to have something made, there's a few requirements to get you started. The very first and most important thing is having CAD skills. So that's why we're starting with CAD. The next thing you need to know is about the processes involved in having those things made and why you would use those processes to make things in that way. So that's not as important as CAD, but it's still important. And then the other thing you'll need is either money, or you'll need money if you want to have someone to make it for you, or if you want to make it yourself with your own machinery, you'll need time, you'll need somewhere to put it, and you'll also need lots of money. So there's two ways of going about it. You can either contract it all out, or you can do it yourself. Okay, so probably the main advantages of using CAM, or computer-aided manufacturing, is that it's faster, it's cheaper, and it's much, much, much more precise than if you make it by hand. One disadvantage though is that it has very big setup costs. The machinery itself is extremely expensive. So unless you want to be setting up your own factory to have millions and millions of things made, you're always better off outsourcing it to somebody else. Okay, I'll just, there's a couple of GIFs here I'll show you of some things getting made with machines. It's pretty satisfying to watch. So that's a CNC lathe, and it's just trimming down a spinning bit of metal. Going back in, how do you go back in? I don't know how to go back into the thing. Okay, and click on it, go to the next one. Next link, no. Yeah, and this is a CNC mill. So these things are extremely powerful and extremely precise, and they just cut through metal like it's butter. So that curve there would be a curve set in a CAD file or in a G-code file, and then the machine just does what it's told. So it's really powerful. Okay, awesome. Okay, so learning CAD really opens up a whole world in terms of what you can make. So CAD is really, in that sense, a key to a very, very big lock to a really big world in terms of making stuff. That world is CAM. So there's two sort of separate worlds with CAM. One world is additive manufacturing. The other world is conventional manufacturing. Additive manufacturing is a bit more recent, and that's sort of like stuff like 3D printing. Of 3D printing, there's lots of different types, but they all have the same thing in common in that they add material onto the job that you're working on, piece by piece until you're finished, whereas conventional manufacturing typically takes material away piece by piece until you end up with the thing that you want. So of 3D printing, there's selective laser sintering, there's fused filament, there's stereolithography, and those terms aren't really that important in terms of when you're learning about it for the first time. But the things that you would probably most likely encounter as a beginner is fused filament 3D printing, because that's the type of ones that they have in the MCIC, and those are the ones that you normally buy for yourself. And of conventional manufacturing, there's two worlds in that, and there's 2D and 3D. So the 2D world is laser cutting, which you'll learn a little bit about today. There's CNC routing, which is like laser cutting, except instead of using a laser beam to cut through the material, uses a spinning piece of metal to cut through the material. And then there's water jet cutting, which is using very, very high powered jets of water to cut through the material. And then there's CNC lathes, which is like what I showed you in the GIF. And then in Plasma CNC, there's also plasma cutters, yeah. And then in the 3D world, there's multi-axis mills, which is that thing that the second GIF that I showed you of the machine cutting through. There's also injection molding, and injection molding itself is not normally done, like the actual molding process is not done by machines. But the molds themselves are made by machines, but it's all automated anyway. Okay, so that's like a really, really basic overview of the sorts of things that the sorts of ways that you can make things using CAD. Okay, so for the 2D CAD that you can learn about really early on, it's actually really useful, especially for things like laser cutting. So if you have like a two-dimensional object you want to cut out of a really, really big sheet of material, you can make something in 2D on a computer, and then you can send that file to the machine and it'll cut it out for you. And it'll cut it out exactly the right size, which is really awesome. So you input a 2D CAD model, and what you get is a full-scaled like end result, exactly how you designed it on the computer. The process goes, you have the CAD file, which is essentially thousands and thousands and thousands of lines, depending on the format of the file. That gets turned into something called G-code, which is basically mathematically defined paths for the machinery of where to move and when. That gets turned into a real-time data that gets fed into the machinery's firmware in terms of all the motors and lasers and things like that. And you probably would see how the stuff that we did with Arduino in our last workshop might fit into something like firmware, because you can control motors and stuff with Arduino as well. So we're really giving you like a suite of tools that you could use to make something from end to end if you really wanted to. 3D printing is almost the same as laser cutting in terms of like the process that it uses from CAD through to the final result, except with a couple of extra steps because it's 3-dimensional instead of 2-dimensional. So you input a CAD model, which is defined as solid 3D data. So it's like a shell of an object mathematically, and the inside of it is the material and the outside of it is not material. So the computer knows where the material is and where it isn't. That gets sliced up into thousands and thousands and thousands of layers, and each of those layers is actually a 2-dimensional drawing like you use for the laser cutter. So basically after that step, it's almost the same as the laser cutter. Each layer gets sent to G-code for the toolpaths. The toolpaths get sent to the firmware makes all the motors move, and then it goes to the next layer. So just basically, it's like the laser cutter. It moves around, does the job, steps to the next layer, and continues on until the job's done. So that's a really brief overview of 3D printing. So now Chris is actually going to show you how to start making things with CAD.
Okay. So can I just ask how many people have actually managed to install AutoCAD and Inventor? That's a bit worrying if nobody installed it. Yeah, who has had trouble installing? Can I just ask? Okay. We've got people around to help, so... sorry about that. Yeah, can I just ask who has had trouble installing? Who hasn't been able to install it? Can you please put your hand up? Do you mind going and help? And I guess... Yeah, I know. Okay, so for today's demonstration, I'm just going to be showing you how to make 2 basic solid shapes. I'll also be running how to actually lay them out on a drawing. And yeah, from there.
Hey Chris, which version?
As new as you can get it. So generally it doesn't matter, like all of them do the exact same thing. The newer one might have a few extra features of it connecting to other programs such as Revit, which is a architectural design program, but generally it doesn't matter which version. So the first thing you want to do in AutoCAD is always ensure that you're in the correct units. So basically you can go through the home, drawing utilities, and then units, and just double check that they're what you normally use. So precision, I normally drop it down. But yeah, one thing is, like, you're halfway through a project, you find your whole thing is in inches. You basically have to do a lot of like restarting again just to get it correct. So it's from the A symbol, you can go down to drawing utilities and then units. Okay. I'll start with a brand new file. Okay, so there's a series of basic drawing tools up here on the top left. You can use these to draw different arcs, different shapes, polygons. Different shapes, lines. So one of the most powerful things about AutoCAD is the ability to snap and move stuff from place to place. So you can actually snap and join them to each other. Yeah. So when selecting stuff, you have several options on selecting stuff. Moving your mouse to the left, after you click it, you'll get a box selection. To the right, and it's a bound selection, which is indicated by blue. So the difference between these is the green selection will select anything that it touches. So as you can see here, the thicker green lines are the thicker white lines are lines that have touched the white green box in some way. These two. However, for the blue box, only this line existed within the entire box, which means that only this line is selected. As part of AutoCAD is additive selection, so anything that you select afterwards will also be added to the selection. And yeah. Layers. So when working in AutoCAD, you will generally work in several different layers, and each layer you may use for different things, such as a different what's called floor plan, a different MEP, so mechanical engineering. I forgot, but it's like different structural stuff like piping and columns, beams, structural reinforcements. So you will generally have them on different layers. So with different layers, you can add a new layer using this small one right here. And you will normally work with them on different colors, line weights, all set from here. So you can load even further line weights such as dashes for hidden lines. And you can also load different colors for the lines. So when laser cutting, you will generally have several different line colors, and depending on the laser cutter, sometimes the cut will be described as red, RGB red, while the engrave is blue. So blue. And when laser cutting, you want to ensure that your line thicknesses are as small as possible. This is because if you have a thicker line color, when laser cutting, it will detect it as a raster and try and cut a whole area or swath out of it for laser cutting. So when you're laser cutting, a raster is more of a engraved to actually create a sort of pattern on it. So images of people or shapes that you just fill out. So as you can see, cut, engrave, raster, and that is dependent normally on your AutoCAD file and the line weights and thicknesses. Yep. Okay, so okay. So when you're got some sort of geometry that you want to work with, say you want to laser cut a badge or something, you generally want to have it on the cut layer. And anything inside it, so anything that is on the line will be cut. So if you draw another, say, circle on the same layer, when you laser cut, you'll end up cutting around the entire circle, cutting through here, and cutting this entire shape out. So you end up with 3 pieces. So when you're laser cutting, ensure that cut lines that you don't want to intersect don't intersect. Does that make sense? So I'll show you on the example. So has everyone actually accessed the example file? So this link here will take you to the example files in the slides. GOO.gl87, capital S, small j, small t, small o. And that'll take you to the example files. Could everyone please load up? Do you want to just go to the back and give me a rough indication when you see maybe 50% of people have their file? Good to go? Okay, so as a demonstration and exercise, what we've currently got here is a top view of an object and a front view of an object. As you can see here, there are dashed lines that actually indicate that it's cut through the object, and that's just a simple top view. Generally, to get the right-hand side view, you can draw from here. So you take a line, take a point, and you can hit tab to actually swap between these. So you tab between the lengths, and what you generally don't care about the lengths, but you do care about the angle. Because what we're going to use is this line to mirror the dimensions of here to the right, so we can get a right-hand side view. Then you take another line and draw an extension from there, and then you can make a copy of that line, CO. So this is the command bar. Anything that you start typing will be treated as a command, and it's a sort of instruction to the CAD on what to do with the geometry. So we're copying geometry, and you specify the origin, and then you specify destination. And then you can keep copying the geometry to every single corner that you can see. So other thing is with arcs. So with arcs, they generally don't have a point, but you can take an intersection. So you first of all hover over the center, and that will give you a green cross. You then can travel along that line until it intersects with something, and you can draw another point. So with this, you've got the basic, like, all the different places from the right-hand side that you will generally see. So you can then take a extend tool. So up at the top, there's the trim, and then there's the extend. And what you do is select the objects you wish to extend to, and you hit enter, selecting that object. You can select multiple objects to extend to, and I'll get back to that. So you select the lines that you wish to extend, and it intersects at that line. So once you're done with the command, you can hit escape to cancel, to end the command, and that way you won't keep running the command. So drawing another vertical line, you can see that it's snapping by the green tinge, and you can just copy that line. Copy that line to the other point. So doing the same thing from here, you can take this line, extend. So when it extends, it will ignore all other geometry in the way until it hits the line that it's extending to. Like that. So the next part is to actually trim the geometry, trim the excess using a trim command. The other place you can find the trim command is from up here, trim. So you select all the objects, hit enter, and what you do is erase all the excess line work that you don't need. And then the final part would be to actually remove these lines of the circle, which is currently hidden, to the hidden layer, which I have already predefined as dash. And erasing all the construction line work. This allows you to actually get the right-hand side view of an object that you wish. As an exercise, I'm going to have you try to do it with the right-hand side here. I seriously don't. Okay, I should ask. How many people actually understood what I did? I'll take that as a no. Go a bit slower. Go through the same again.
Maybe just explain the extent.
Okay.
Like really in detail, because most of that was the extent that you.
Yeah.
Just maybe extending one line, all the steps involved. And trim is actually really easy.
Yeah. So I'm just going to give you a brief explanation of the extend and trim tools. So with the extend tool, what you do is you start selecting an endpoint. So any line that you select. So first of all, you select the endpoint, which line that you want all the lines to extend to. Then you select the lines that you wish to extend, like that. And they will extend to it. So if I have two lines and I wish to extend my line, these three lines, it will extend until the first line intersects. So what the extend tool does is just extend all the lines that you select until it meets the endpoint on one of them. However, since this path will not intersect this line here, it is unable to be extended, as you can see. The opposite of extend is the trim tool. which you can then use to actually trim the geometry, so you can trim excess lines that go outside. You can trim between them, and you can trim the other way. This is useful for when you're shifting walls and lines of the plans. So say you want to move the, say you have to move a wall back a bit, you can then just extend the lines until the lines hit the wall for a intersecting wall. Or, yeah.
So is the purpose of this just to like construct different perspectives?
Yeah, so generally you're just constructing different perspectives here. However, in a floor plan and like line work, you may know that you have, say, something like this, and you know that you have a wall, a line that's 600 millimeters off from the back one. As such, you can choose to take this and extend all lines until it hits it. Or the other way, which is a lot slower, is you manually extend each of these lines by selecting them and then selecting the endpoint and dragging it up. So it's just a cheap, basically a faster way of actually extending lines until they hit each other. Trim. A trim is basically, say, I want to cut all these lines at that point, in which case I would then need to take this and shorten each one to that. However, if, say, I want to say if I wish to have the line in the middle, like cut in the middle by these two lines, then if I would have to take this line, extend it back, draw another line that extends from it, and connect it. Instead, using a trim, you can simply just cut the line in the middle. Okay. So I'm wondering, has anyone actually been able to draw the right-hand side section of this, right-hand side view of this object? Which should look like this if you look at the 3D perspective. Does anyone need help? Yep. So I'll let everyone have a try and come around and help. Okay, so basically what you know is these two dimensions here, right? You can draw a line there at 45 degrees. Yeah, you can tap every spot between them. So you can tap every spot between these ones. And this angle is the angle of the line. So you want that one to be 45. So you use so you track all every spot between these. you select the tool that so you've got two selections. Green is anything that touches blue is anything that is one. So it's only green the entire class. Green only touches. So with the extend tool, you select your tool that you want to extend to.
You don't touch my screen. Oh, it's touchscreen.
Okay, so I've been going around and there's quite a few questions about how you select these circle dimensions. So when you go through on the line tool, like this, you can find the circle center point by just hovering over the circle and it'll just hover at the center point. Once you're there, you can put your mouse over it and that will allow you to actually create a locking point. So when you travel as orthogonal to the circle, you'll start seeing the green lines, which is a snapping point. So when you're orthogonal to the circle, on the circle, like orthogonal, you can go to the top here and find where that line intersects with the line. And from there, you can draw a horizontal line across. So with the same thing, you can snap lock the bottom one and draw another line across. So with this line, the mirroring line, it doesn't quite matter the length as long as it's long enough, but you want to ensure that this line is exactly 45 degrees so that it mirrors it at 1:1, the vertical dimensions. So taking this single line, I'm just going to copy that point from there all the way up to these ones here. Just copy them across. Taking this, I then extend these lines. Sorry. I extend these lines until they meet it. Then I draw vertical lines. Escape, clear that. I draw vertical lines coming straight down.
Snap with the center of the circle. How do you make it snap onto the tangent?
Okay. So just what I did. So just how to snap it to the tangent again. Tap your cursor over the center of the circle, the edge of the circle. Once you've selected the line tool, move it to the center to create a snapping point. And then you'll see it having a green plus at the center. Then with that, you can actually snap it to anything that's along the X or along the Y of the circle as it hits the line. So you can even snap it down to the very bottom or very top or to the sides as long as it is along the X or the Y of the center of the circle. You can also use other things as snapping points, such as the endpoints of a line, by simply just hovering over it and then just traveling along it. You can clear the snap points by going back over the point, and that erases the snap point. So you will stop snapping to those points again. So with this, you want to extend these lines until they meet it at least. Draw extra lines from here to the bottom. Like this. Then you want to take horizontal lines across. So see that I haven't made this line long enough, I can just simply take this line, extend it, this line's to meet it. So I've got the general shape now. What I need to do is cut all the excess line work that I don't need. So I take a trim and cut the excess line work here. Sometimes you have to reselect the line work again when you're trimming, and then just delete the excess. Yeah. Ooh. Yep, just make sure you erase everything that you don't need. If anyone has actually managed to successfully draw it, you can draw your own shape. Yep. It's meant to be on that right side. Okay, so I'll explain why Thinking we might have to jump it. Yeah. Do you know where these are? Okay, so there's no actual there. So I'll explain this later. I did explain later, but you probably have you can stop the line. You go, yep, you drop this one down, yep, and put them in. So I'll reproduce simply the layers, so we can reduce that down. So you go layer properties. Yes, okay. So as you can see here, the line that dash create the layer and all the lines on that layer will be the same way. So when you're laser cutting, you've got two separators. You're cutting one for grading, and so you have one grade for grading. You first of all do a line, like a line. Alright, you can practice it. I try to be nice. And then, I'll work my way backwards. You should get an email with new ones. So when I'm looking, you need it's just nature. Take a breath. I make the best breath.
It's the same force every let me quit. Yeah, I know. Like, I already one time, like, I felt like
She has like it's like adequate human at some bar. Oh, there he is.
Okay. Okay, so I'm just going to talk a bit. So here I've opened up the layer properties, which can be found here. So as I stated earlier, each layer has associated properties with the line weight, line type, and thickness. So on the status on the left here, you can see a tick. That is your current layer. That is the layer you are currently working on. So any geometry you draw will be put onto that layer automatically. You can swap between them by simply double tapping the layer you want to work on. Next is the on, which just changes the visibility, and you cannot turn current layers off, otherwise it pops up this. Well, you can turn it off, but yeah, you can't see what you're working on. So say I were to draw a line on my current layer, I won't see what I'm working on. Freeze you can generally ignore. Yep, you can't freeze it. And lock. So once you lock a layer, you can select it still, but anything you do to it won't affect it. So say if I were to try and move this, it won't move the locked layers because they're still locked and they can't be moved. You can, however, use lock layers for the extend and trim. Line color, you can use it for laser cutting and selecting line colors. You may also use it to highlight certain properties of your design. Line types. So here's how you actually dash the line. So you select the line and change the property to a dash. And default thickness, well, you can have different line thicknesses for your elements. So that's not going to make much on the drawing, but when you get to actually printing the drawing, it will actually affect how it looks. Yeah. So then I'll go over overrides. So in certain drawings, you may have a layer that you don't want to change the entire layer to a different line weight, but you may want to change certain elements. So for this circle, you may want to change that to, say, black, which is different from the layer, and that just overrides the layer. You can just return it back to its original by changing it back to by layer. Next, annotation. Okay, so with annotation, you can put text in, dimensions, and yep. So you've got several different default options here. It's under annotation right here. And you can go standard, and what you do is dimension. Ignore that. Draw those two, and that just dimensions this point here. So since I did the dimension on the hidden layer, the line is currently dashed, but I can change the layer on here to be, come on. Yep, I hate playing around with this. Unlock that, change that. Yep. So you will notice if you zoom in the text right here, this is because the font size is a bit small. So you want to go annotation. No. Okay, so with the font size, it comes as default 2.5. To actually add more font sizes, you have to type in the text size command. Oh my god. Pretty sure. Pretty sure it should be here. No. Text size. So you can set different text sizes, and yeah, that's how you add more different font sizes. And yeah, changing it is a pain. Oh right, I know why. So you can go to dimension style, and from here you actually modify the actual fonts used. So the current text size is 0.18. You may just want to up that to about 10 to make that visible. So with dimensions, you can select a line to dimension the line. You can select a start and end point. Or and drag it around, you will get different heights and dimensions. You can use the same snapping to lock it. And for circles, you go radius. And then you've got hatching. So you can hatch it, you can grade it, and you can do other things to it. So for a solid, you go pick points, give it a moment, it generally lags, and just tries to fill in whatever boundaries you set. Like that. And once you've done that, you can, however, remove Yeah, this is one of the most annoying parts of it. But you can remove them by using the remove tool here and selecting the hatches you wish to remove. So, delete that. Okay. And then I'm just going to describe the process of layering out on a sheet. So if you go down to the layouts on the bottom, you can lay it out on pieces of paper, which are then sent to the printer. So within your layout, you have a dashed line around here, and this is your printable area. So that is normally defined by your printer. Anything not within the box, bounded by the dashed lines, will not be printed. So if I were to just go Control P, don't show me that again. Yep. So since this line here was within the box, it was printed, otherwise everything outside of that box was cut out. So to change your actual sheet, you can go right-click Layout, Page Setup Manager, modify that, and you can set your printer. So you've got the general printer PDF, and then you've got the different paper sizes. So you got, that will all depend on your printer, but I'm going to set as ISO full bleed. And then I'm going to set the scale as 1:1. Sometimes you can, there's two ways of doing this. You can either choose to set the scale as 1:1 and change your viewport to the correct scale, or you can set this as the scale you want it and set your viewport to 1:1 scale. So if you have multiple viewports on the same one, then you'll choose a 1:1. So this is your viewport here, which is linked back to your drawing, and it just displays this area here around it. So select the viewport, and you can change the scale here on what you want to view it at. So you can say 1:20, and it scales your drawings at 1:20. You can say 1:100. Close that. 1:100. Or 1:10 and zoom in. So if you don't want, you can double click outside to actually stop the selection. So you can move these outside. You can also add more viewports. So from layout, rectangle, and then you can just create another viewport. So we have a second viewport. You can select a different object, and you can scale it at a different height, size. Moving the viewport around will actually move the inside, but you can double tap in to actually select and go into the viewport to go in and move around. Double tapping outside will escape the viewport, and that's how you lay out your work on a piece of paper for printing. You can have multiple layouts on multiple sheets of paper for different parts of your drawing. So say you've got documentation of a lot of different floor plans, you lay out on a separate layout each to actually print on separate pieces of paper. Yep. And that's about it for the AutoCAD section. Yep. Any questions about AutoCAD?
Can you scale it again?
Sorry?
Can you scale it again?
Scale.
Yeah, can you scale it?
Scale the drawing.
Yeah.
So you select the box that you want to scale. So say this one. From the bottom right hand here, down the bottom right hand side, there's a 1: something as your current scale. I really need to zoom on this. But it's down here on the mini bar. And from there you can select the scale you wish the drawing at. One trick is to actually take a viewport line, and you can set that as a different layer. So actually So set as layer 1. I can change that line to the new layer. And so when I print it, I can just hide the line so that when I print, I don't actually see the outlines of the boxes. Yeah. Can I ask, is there any other questions? There's pizza outside, then I'm going to run with Inventor afterwards, if there's anyone sticking around. If not, then I'll leave that for next week. Excellently. Yep. Yes, I'm going to be covering which is 3D CAD. Yep. So the slides are accessible via this link here. Yeah, so just use this link here.
Alright then.
Yeah.
So, can we just kind of take a note down?
I'm just going to stop this recording.